For this week's lab, we're going to talk about visualizing text. There's a ton of information in text format. It's not necessarily easy to visualize it. Frankly, I think a lot of the visualizations out there for text are not very good, but there are a few examples that are interesting that you're going to play with, and I'm going to use this opportunity of the lab to kind of give you an overview of the things that are out there to visualize text. So we're going to move pretty quickly through this outline, but what I want to do for you is cover the fundamentals of text visualization. I'm going to talk quickly about specific topics. That's looking at raw text and text with links, which are the two main spaces that we're going to focus. And then we'll talk briefly about text with space and time. And you'll do some practical design exercises, which are the lab part of this. So the problem with text is that characters are a visual representation of the text, the language, the things that we're saying. The challenge that we face is that we want to find a way to visualize text, but that doesn't show all the text, because otherwise you could just read the document. But if you cut down and don't show the whole document, is it still useful? Do you get information about detail and context if you strip away a lot of the words? So this is the premise of text analytics, which is independent of visualization. It's trying to summarize text, trying to extract keywords, find themes, and then also text visualization, trying to visualize text. And often those two things work together. There will be text analytics running in the background, and then you will visualize the output from those. The key problem here, and this is a really interesting one to think about because it ties back to so much of what we've covered in this class, is that text is sequential. There are words that you read from the beginning to the end. There are sentences that you read beginning to end. There's paragraphs you read from beginning to end. And so you have to do it in order. But visualization works from doing a whole bunch of things at once. We can look at a visualization and at the same time see the lines and the colors and the shapes and the outliers. We don't need to look for each of them individually. We can, in parallel, see all those things at once, which is why we're so good at extracting information quickly from visualizations. So it's a challenge to think about text where the order matters. If you change the order of the words in a sentence, you can completely change its meaning, let alone rearranging all the words in a document. If that sequence matters, and every word matters, then we have a hard time doing a bunch of things in parallel with text. So it kind of raises this question of, is there a contradiction between trying to take advantage of parallelism, which is so important to visualization, while visualizing text? Here's some examples of text data just to help us think about how to address that problem. So Wikipedia, huge. We have a ton of text in Wikipedia, and there's lots of things to visualize there. You can visualize links between pages, you can visualize editors, you can visualize comments, but we also may want to understand the text. But it's huge. Common tasks that people have: looking up particular text, navigation, linking between pages. And so knowing those tasks, we can ask ourselves questions about how might we visually represent something we know about the text to support any of those things. The Bible is really commonly used as a text example because it's not copyrighted, it's freely available, a lot of people have a cultural connection to it, and the kind of tasks that people are looking for, obviously finding and reading passages, but also finding connections, exploring and seeing if there's new things in it. And this is certainly not just the Bible, but any text document that you have, especially books with a lot of cultural meaning. People want to explore those. And so there's a question of, can we visually extract insights from the text to show something that we don't know? Legal documents, big challenge. There are tons and tons of legal documents produced in every case. And it's important to be able to go back through those, to find references, to look for precedent, to make queries. But the volume is so big that it's essentially impossible for anyone to review all the documents in front of them. So is there a way that we can use visualization to help find those things that people need to locate? And then things like politics, looking at political speeches, campaign documents. We want to get an overview. What are the kind of things that politicians are talking about? What's the message they're putting out? How does it change over time? Can we take the text of those speeches and documents and analyze it and visualize it in some way? And ideally, we want to be able to do all this without a lot of manual effort. You certainly can extract data from all of these places and build yourself a data set that you can visualize, but then you're kind of visualizing hand-curated data. You're not visualizing text. So there's a question about how can I automatically extract something from the text that feeds a visualization that will support these tasks. The key here is that visualizations about text are not designed to replace reading. You still have to read if you want to understand what's in the document. Visualizations of text should support other tasks, other understandings of the text beyond just reading what's in it. So let's start with the example of raw text. We want to visualize that. What are some visualizations that just look straight up at text for us? If we treat text as data, we think, what type is it? We have a word. Okay, is that a nominal? Is that like a category? It's not really. Words have their own meaning that's different than we would get like with categorical data. The properties that we have of words or of text is that it's high dimensional. Every word kind of becomes its own dimension. You care about more than just are two words equal to each other because they can have different meanings and be the same word. Meanings are really important, as are the relationships between words. And that's not just are they the same, but also are they antonyms, are they synonyms, are they often used together, are they describing the same categories of things? So there's a lot of connection of meaning between those words, but it's not necessarily something that immediately pops out from a text document. So one approach that we use when we're dealing with text is to ignore the sentences and the paragraphs and just throw all the words into a pile together. We call it a bag of words. And it ignores the order, it ignores relationships in the text. We just focus on the words. We can then treat a document as basically a vector of term weights. That's a fancy way of saying we list all the words and count how many times they show up in the document. Each document has a list of words. Those are the dimensions. The value tells us how many times it appears. And you can weight that, and there's a variety of fancy ways to do this, but simply you could just count it and that works fine. And then if you have a bunch of documents, you can put them into a matrix where you have all the words that appear in all the documents on one axis and all the documents on the other axis, and each cell indicates how many times a word appears in the document. This is used for all kinds of interesting math that we do with text. For example, web searches use a variation of this, representing text as matrices and doing some fancy math on them. And it's also used for some visualizations. Text processing is also important here, and we're not going to dive deep into natural language processing, which is a really fascinating field by itself. But just a few things to talk about. These are really basic natural language processing terms, which are good to know. So tokenization means that you're going to break the text up into terms. Terms are essentially words, but sometimes multiple words become a team. So something like San Francisco. There's two words, but it's really one thing. And so tokens are basically words or phrases that are always used together, like San Francisco. Stemming is used to normalize terms, and what that means is we have many variations of essentially the same word. So I could say run, ran, running. Those are all the same word. And if somebody is searching a document collection for running stuff, you want to pick it up if it also says run or ran. So stemming is basically cutting off the end of the word so you just get the root. So it doesn't help with run and ran, but it helps with run and running and runs. You cut the end off so you just have the core. Stop lists are a list of common words, basically. So a, the, is, if, all these words that appear all the time that don't carry a lot of meaning themselves. They're used to create meaning with their relationships with other words, but they're not really describing any stuff themselves. They're also super frequent in the documents, and so if you're trying to find out what's a document about, well, the most frequent words are going to be the ones that are on a stop list, these super common words. And that doesn't tell you anything about the document except that it's written in a language that uses common words. So we often have a stop list of words that we don't care about, that don't convey meaning, and we strip those out before we do the processing. Entity identification is where we find properly named things. So people names, places names, organizations. In English, basically anything you'd capitalize tends to be something that would get an entity identification, a formal name. And what you end up with is a bunch of terms at the end that you can order and sort, and deal with based on their weights, how often they show up in a document. So these are common text processing techniques that you would do with any natural language toolkit that gets you to a set of words that's going to have the most meaning that you then could visualize. How do we visualize stuff? Counting words is a great way to do this. Wordcount.org is an example where it has the about 87,000 most frequent words in English. They're ranked by how common they are. You can go ahead and try it out, but you can see a whole bunch of words at the beginning, which would be on everybody's stop list. The, of, and, to, a, in. We'd throw all those out because they're used so often. So that's an interesting visualization to show you how important words are. But because the most frequent ones are so common, everything else just looks really small. Word clouds and tag clouds are another common way to do this. You've certainly seen these. And basically, to create a visualization of a word cloud, you're going to count the frequency of words. You're going to remove those stop words. That's going to include all the common words, plus maybe other ones that you want to ignore. And then you basically make the more common words that appear more frequently bigger, and the less common words smaller, and then find a way to lay them out on a canvas. So this is one example, but there's lots of ways that you can do it. Wordle is one example where it has a nice kind of space-filling layout that you can use. So they're not all scattered around, they're packed in really tight. And for your practical exercise, I want you to actually try it. So you're going to go and try making your own Wordle. So there's instructions up in the exercise option on Canvas, but basically you're going to pick a data set, you're going to create a Wordle, edit the properties a little bit, go ahead and post that. Shouldn't take you long, but I want you to post that in the discussion board. And of course, as always, comment on other people's. So that's working with raw text. Then we have text with links. Obviously, there's a ton of this on the web, and there's other ways to find links between text. So one example of this that we've looked at already is the visual thesaurus, where you have words that are connected to other words, in this case mostly by synonyms. I still question how useful this is and if it's better to maybe use just a thesaurus where those words are written down, but some people like to have the visual space. And of course you can try the demo of that yourself. But it raises this question, what are the weaknesses that we see in word clouds? Well, it's a suboptimal visual encoding. You can adjust the size, but position isn't really useful. And if you do adjust position, then you can't mess with the size as much. Size coding also tends to be inaccurate. It doesn't necessarily reflect the relative popularity of the terms. And that's okay for making something that looks good visually, but not necessarily for creating information or insight. It may not facilitate comparison. The layout kind of moves around, so it's a little bit hard to compare one word to another or one document to another. The term frequency may not be meaningful, so we're counting how often words appear, but even if we get rid of stop words, sometimes it doesn't necessarily tell us the insights. For example, there may be kind of categories of words that describe different things that we're looking at, and those categories are important, but the words themselves may each be infrequent and not convey that there's some really important themes there. And finally, it doesn't show any structure. So a word tree is one way that you can search in text where it respects the order. So you can pick a phrase and you can see all of its context. So here we're looking at an example that we saw before with the I have a dream speech, and you can find that phrase I have a dream and then look at what always comes after that. And for example, if we go up the upper branch, we see that that is a term, and then what follows I have a dream that? Well, there's two options. One day, which has a bunch of text to come after it, and then one other option. If we go up again, we can ask what comes after I have a dream that one day, and then there's a set of options there. So it shows us the structure and relationships within the data in a way that we couldn't see if we were just using a word cloud. We wouldn't see this kind of relationship in the text. And again, this is something that you've tried before. You can run the demo, plug in your text, just copy and paste it in, and it's going to make you an example. Now, I want to do a practical exercise with this again. You have already tried this. If you remember back to week 3, I already had you try Wordtree, but I want you to try it again with the intent of thinking about how it helps you understand text. You did it with the I Have a Dream speech last time, but I'd like you to pick something else. You can pick whatever text you want. Try something like a poem or a speech or lyrics, especially where there's going to be repeated phrases, because that will help you take advantage of its features to see a little more insight. And then search for a phrase and see what you can find there. So this is a good example that I want you to just revisit to see how we can look at structure in text with that eye towards the tool. Okay, so what we've been talking about so far are basically single documents, single glob of text. But sometimes we have a bunch of documents. So those could be a bunch of papers, a bunch of legal documents, a bunch of images with tags and descriptive text on them. So we should talk about how we handle those. Typical use cases, we want to summarize those documents, we want to query them, we want to see connections between documents. User groups, analysts of any type. Analysts tend to have to work with large collections of documents and analyze what's in them. So lots of domains with analysts will want a tool like this. Journalists and investigators are specific examples where they're really trying to ask pointed questions and get insights out of large document collections. Some examples of how you might visualize that. Document cards are one. So this is an example of it over here. There's a video demo down here that you can check out. It essentially creates a little visual card for each document that you can scan over and zoom in on. I gotta say, this is one that I don't think is especially effective by itself. I don't want to be critical of other people's work, but I don't think I'd probably use this. It's a little hard to get an overview. That said, for certain experts and people working on certain problems, it can be really useful to have a visualization like this. So go ahead and check out that video and you can see it at work. And then we also want to talk about text and space and text and time. So how do we lay out text in a spatial environment? Well, you could model each document as a node in a graph like we talked about with networks, and you can add edges for documents that are related. So that could be co-occurrences of words, links between documents. There's all kinds of ways to find those links. And then you can use any kind of graph layout algorithm that you want. Some of these are what you saw in Gephi and that you played with. And the result is that you get a kind of two-dimensional network diagram, sometimes called a self-organizing map in visualization terms, but we do so much more with networks now than they did back when this was invented that we're now pretty familiar with network terminology. And so that's an interesting way to get some results. But that's not the only way to see text laid out in space that's meaningful. There certainly have been a bunch of attempts. Again, I'm not super impressed with a lot of them, though I do like this one. These are typographic maps. So here we're looking at a map of Washington, D.C., and spaces are created from text that says what they are. Is this useful as an information visualization tool that helps you gain more insight? Probably not. But at least this one looks cool, unlike some of the other examples that are out there. And then finally, just quickly to talk about text and time, we've spent quite a bit of our time talking about how we visualize time, and text visualized over time takes a lot of the same tools and just uses them with text as the input. So this is an example. There's a lot of stream visualizations like this for looking at text. These are themes from Fidel Castro's speeches from 1959 to 1961. Each theme gets its own kind of line in this stream, and the width indicates how often it was discussed. And then there's marks across the top to show you specific events that were important. So here, taking techniques that we know for visualizing time and then using insights about the text that have been already extracted, themes in this case, to show them visually. In a couple weeks, I think the very last lecture of the semester, we're going to look at a case study of doing text analytics along with visualization. So if you're super interested by this, you may peek ahead because it's looking at kind of fancier ways to do automated text analysis and visualization. But to kind of sum up what we've looked at today, this is intended to be a lab, so we didn't probe all of this super deeply, but it's important to know that text is a challenging yet also abundant source of data that we might want to visualize. The techniques out there are not fantastic at this point because it's a really hard medium to visualize, exactly because it conflicts with a lot of what we want to do visually. We want to see things all in parallel, but for text to really understand what's there, you have to get it in order. So if you're looking for a challenging space to work on creating new, better, useful visualizations, focusing on text is a great example. As far as I'm concerned for today, though, what I want you to do is get a little bit of experience trying a few of the tools out there that have got some traction, that are more popular, that I think do help us get some insight, and use that as a basis for thinking about how to include text in visualizations going forward.